Crystic gel coats have been formulated to ensure a low porosity gel coat surface with a superior gloss finish. The viscosities of Crystic spray gel coats have been optimised to ensure ease of handling when spraying. To ensure users achieve the optimum gel coat surface finish, there are a number of techniques that should be followed when spray applying a gel coat, and these will be shown in this film. To spray a gel coat, you can either use a pneumatic spray gun or airless spray equipment. Pneumatic spray guns tend to be used for low production runs or on small moulds. For faster production runs or gel coating larger parts, airless spray equipment is preferred by many companies. To achieve the best results, we recommend airless spray equipment with internal mixing, as this ensures a more thorough mixing of the gel coat and peroxide. We also recommend air-assisted equipment, as this allows the gel coat to be sprayed at a lower pressure, giving reduced risk of gel coat porosity. The equipment used is an airless spray machine from Matresseur Composites, although similar models can be purchased from other equipment suppliers. It has internal peroxide mixing, air assistance and a heater. This is a medium-size airless spray machine with a pump ratio of 1:15. On the top right, the manometer allows the pump pressure to be adjusted. The manometer in the middle allows the user to adjust the air-assisted pressure on the top head of the gun. The manometer on the left side allows for the peroxide pressure to be adjusted. The pot on the bottom left side is an acetone cleaning tank. A static mixer in the gun allows the proper mixing of peroxide and gel coat. A scale also allows the adjustment of the peroxide level. For the machinery, the most adapted nozzle is 425 or an equivalent nozzle with a 40-degree angle. The airless equipment needs to be fully checked before use. The gun and the nozzle need to be clean, and if any old product is remaining in the pipe, it should be removed before use. A medium reactivity MEKP catalyst like Butanox M50 should always be used at a 2% ratio to the gel coat. Nothing should be added to the gel coat like acetone or styrene, as this may affect the final properties and surface finish and cure of the gel coat. Workshop and material temperature should be maintained at a minimum of 15 degrees centigrade. The gel coat should be gently stirred before being connected to the spray equipment. In this demonstration, the gel coat is decanted into a hopper. However, other machines are available which pump directly from the drum or keg. Before starting, ensure that an efficient extraction system is switched on and that individual protection equipment is being worn. To achieve the optimum spray pattern, the right amount of pressure needs to be applied. This is dependent on the viscosity of the gel coat, the size of the nozzle and the pump on the machine. The following demonstration shows very clearly what happens when the pressure is too low. As you can see, at 1 bar, the spray pattern is not uniform, the gel coat has obvious stripes in the coating and the thickness is uneven. The pressure on the machine is increased to 2.5 bars and you can see that this is helping. The spray pattern is wider and more even, but there is still not a uniform coating of gel coat on the top and the bottom, so the pressure needs to be increased. The pressure is increased to 3 bars and you can see the coverage is much better. The thickness is still not even, so rather than increasing the pressure further on the pump, 3 bars assisted air is applied at the top head gun. This results in a perfect spray pattern which will ensure the optimum gel coat surface with minimum risk of microporosity. When the pressure is increased to 4 bars, you can see that considerable mist is generated, causing gel coat wastage outside of the mould. There will also be a greater risk of microporosity and colour separation. If this type of problem occurs, you must reduce pressure on the machine. This demonstration shows the technique to use to achieve the best gel coat surface to limit any problems of microporosity or colour separation, and to ensure an even thickness to avoid gel coat cracking. An even thickness also aids long-term UV resistance, as uneven patches will weather at different rates, causing the gel coat surface to look patchy over time. As you can see, the gel coat is being sprayed at a distance of 60 centimeters away from the mold. It is being applied horizontally from left to right, then vertically from top to bottom. This cross-layering technique is very important to achieve an even thickness and to encourage good air release. There is now sufficient gel coat on the mould, and this should be checked to ensure it is 0.5 to 0.6 millimeters thick. Different nozzles can be used depending on the size of the part being sprayed and the size of the spray equipment used. A nozzle will be chosen according to its diameter and its angle. The flow rate is dependent on the diameter, and the shape of the spray pattern is dependent on the angle. A 223 nozzle with a 20-degree angle has a narrower spray pattern and so is more suitable for smaller parts. A standard size nozzle is a 425 with a 40-degree angle, which, as you can see, has a wider spray pattern. A nozzle like the 625 being used here with a 60-degree angle has a wider spray pattern and is much better for large parts. If this nozzle was used on small parts, there would be a lot of wastage. Gel coat should be sprayed at an average distance of 60 centimeters from the mould. If an operator sprays too closely to the mould, as you can see here, the gel coat starts to sag, which will affect the surface finish of the final part. Users should make sure they hold the spray gun at the correct angle. The following demonstration on a horizontal mould shows what happens if the gun is held incorrectly. The correct way to spray is to point the nozzle downwards. If the wrong angle is used, as you can see here, the user will overspray and this will cause wastage. At low temperatures, gel coats become thicker. This demonstration shows what happens when a gel coat is sprayed at low temperatures. The gel coat spray pattern is not even and a striping effect occurs. This can cause porosity. It is important that the gel coat is a minimum of 15 degrees centigrade to spray well. The machine used in this demonstration has a heating facility to ensure the gel coat is sprayed at the correct temperature. The demonstration shows a gel coat gun where the catalyst has been mixed into the gel coat internally in the head of the gun before it is sprayed on the mould. Alternatively, a spray gun head can be used where the catalyst is mixed externally to the spray gun, as shown in this demonstration. To achieve the best results with a good surface finish, we recommend airless spray equipment with internal mixing, as this ensures a more thorough mixing of the gel coat and peroxide, and therefore avoiding a risk of uncured gel coat hitting the mould surface. In this demonstration, we are going to show you how accurately and quickly a robot can apply a gel coat. First of all, the operator shows the robot how he would spray the part by spraying using the robot's arm. Once this has been done, the robot can spray independently and mimics the exact technique that the operator used. Many more companies are moving towards investing in robots to spray as they achieve huge productivity improvements, higher quality levels, and robots offer many health and safety benefits. Please contact Scott Barder if you would like more information. Make sure the correct amount of pressure is applied. Spray the gel coat at a distance of 60 centimeters away from the mould using a cross-layering technique. Choose the correct nozzle size for the size of part being sprayed. Make sure the gun is pointed at the right angle to the mould. Make sure the gel coat is sprayed at a minimum of 15 degrees centigrade. To achieve the best results when spraying gel coat, we recommend airless spray equipment with internal catalyst mixing.